Most people think artificial intelligence is about intelligence in the same way humans are intelligent. They imagine machines that think, understand, and perceive the world like we do. But the truth is much more subtle and much more fascinating. Artificial intelligence doesn't see the world the way you see it. It doesn't hear the way you hear. It doesn't feel, interpret, or experience reality the way you do. What it has instead is something called perception. And perception in artificial intelligence is both powerful and deeply limited at the same time. When we talk about perception in humans, we mean the ability to take in sensory information, light, sound, touch, and turn it into meaningful understanding. You look at a face and instantly recognize emotion. You hear a tone of voice and detect sarcasm. You walk into a room and sense tension without anyone saying a word. Your perception is shaped by memory, context, culture, biology, and emotion. It's layered, complex, and deeply embodied. Artificial intelligence, on the other hand, perceives through data. Cameras become its eyes, microphones become its ears, sensors become its skin. But what these devices capture is not meaning. They capture raw signals, pixels, waveforms, numerical values. AI systems transform these signals into mathematical representations. Images become matrices of numbers. Sound becomes frequency patterns. Language becomes tokens and probabilities. For a machine, perception begins as patterns in data. Take computer vision as an example. When an AI system looks at a photograph, it doesn't see a dog running through a park. It processes millions of pixel values, identifies edges, textures, contrasts, and shapes. Through layers of neural networks, it extracts increasingly abstract features. First simple lines, then shapes, then more complex patterns. Eventually, it assigns a probability that the image contains a dog. Not certainty, not understanding, just probability. And yet, that probability can be astonishingly accurate. Modern AI can recognize faces, detect diseases in medical scans, identify objects in real time for autonomous vehicles. The system learns from vast data sets. It adjusts internal parameters, sometimes billions of them, to reduce error. Over time, it becomes incredibly good at mapping patterns to labels. This is perception through statistical learning. But here's where it gets interesting. Human perception is not just about recognizing patterns. It's about interpreting them within context. If you see someone running, you might think they are exercising, late for a meeting, or fleeing danger. Context changes everything. AI systems often struggle with this kind of flexible interpretation. They are highly sensitive to the data distribution they were trained on. Change the lighting, the angle, or the background in subtle ways, and performance can drop dramatically. This reveals something important. AI perception is not robust in the way human perception is. Humans can recognize a friend in poor lighting from a strange angle or after many years. Our brains generalize effortlessly. AI systems generalize only within the boundaries of their training. Outside those boundaries, they can fail in surprising ways. Another dimension of AI perception is language. Large language models process text as sequences of tokens. They don't understand meaning in a conscious sense. They predict what word is likely to come next based on patterns learned from enormous amounts of data. And yet, the output can feel remarkably coherent, insightful, even empathetic. This creates an illusion of understanding. Illusion is not the same as experience. AI systems do not have subjective awareness. There is no inner world behind the computation. When an AI describes a sunset, it does not feel awe. When it discusses grief, it does not feel loss. Its perception is functional, not experiential. It maps inputs to outputs according to learned statistical relationships. Still, dismissing AI perception as just statistics would be a mistake. Human perception is also deeply statistical at a neural level. Your brain constantly predicts what it expects to see and updates those predictions based on incoming signals. Neuroscience suggests that perception itself is a form of probabilistic inference. In that sense, AI and human perception are not entirely alien to each other. Both involve pattern recognition and prediction. The difference lies in embodiment, consciousness, and lived experience. Embodiment is crucial. Human perception is grounded in a physical body interacting with the world. You feel gravity, you sense temperature, you move through space. These bodily experiences shape how you interpret sensory information. AI systems, unless embedded in robots with sensors and actuators, lack this grounding. They process representations detached from physical experience. This can lead to gaps in common sense reasoning, things that are obvious to a child but difficult for a machine. Consider something simple. If you drop a glass on a hard floor, it might shatter. A child understands this through lived experience. An AI system must infer it from data. If the training data does not include enough examples, the system might not predict the outcome reliably. Human perception is intertwined with action. We learn by doing. AI perception, in many cases, is passive pattern consumption. Bias is another critical aspect. Because AI systems learn from data generated by humans, their perception reflects human biases. If a dataset overrepresents certain groups or contexts, the model's predictions may become skewed. For example, facial recognition systems have historically performed worse on underrepresented populations. This is not because the algorithm intends to discriminate, but because its perception is shaped by the statistical structure of its training data. This raises ethical questions. When AI systems are used in hiring, policing, healthcare, or finance, their perception influences real-world decisions. A misclassification is not just a technical error, it can affect lives. Understanding the limits of AI perception becomes a matter of responsibility. We must ask, what does the system actually perceive, and what does it miss? There is also the question of multimodal perception. Humans integrate sight, sound, touch, and more into a unified experience. Increasingly, AI systems are being designed to combine multiple data streams, images, text, audio, into shared representations. This improves performance and creates more flexible models. But even multimodal AI does not achieve the seamless integration of a human mind. It fuses data mathematically, not phenomenologically. And yet, the trajectory is clear. AI perception is becoming more capable, more adaptive, and more integrated into daily life. Autonomous vehicles rely on perception systems to navigate complex environments. Medical AI assists doctors by highlighting anomalies in scans. Recommendation systems perceive your preferences based on behavioral data. In many cases, AI perception operates quietly in the background, shaping your digital experience. This leads to a subtle shift in how we think about reality. Increasingly, machines are intermediaries between us and the world. Algorithms filter news feeds, prioritize search results, and curate content. Their perception influences what you see, which in turn shapes your own perception. There is a feedback loop between human and machine perception. The future of AI perception will likely involve greater contextual awareness, improved generalization, and tighter integration with physical systems. Researchers are exploring self-supervised learning, reinforcement learning, and embodied AI to create systems that learn more like humans through interaction, exploration, and prediction. The goal is not just better pattern recognition, but deeper situational understanding. But we should remain clear-eyed. No matter how advanced AI becomes, its perception will remain fundamentally different from ours unless it develops subjective consciousness, a question that remains deeply debated and unresolved. Intelligence does not automatically imply experience. A system can perform tasks that require perception without ever having perceptions in the human sense. So what does this mean for you? It means that when you interact with AI, you are engaging with a system that processes patterns, not meanings. It can approximate understanding, but it does not live inside the world it describes. Recognizing this helps us use AI wisely. We can appreciate its strengths, speed, scalability, pattern detection while acknowledging its limitations, context sensitivity, lack of embodiment, susceptibility to bias. Perception in artificial intelligence is not about machines waking up and seeing the world as we do. It is about transforming raw data into structured representations that enable action. It is about probabilities, models, and optimization. It is powerful precisely because it does not get tired, distracted, or emotional. And it is limited precisely because it lacks the richness of lived experience. In the end, exploring AI perception teaches us something profound about ourselves. It forces us to ask, what does it really mean to perceive? Is perception just pattern recognition, or is it inseparable from consciousness and embodiment? By building systems that mimic aspects of our perception, we begin to see the contours of our own minds more clearly. Artificial intelligence may never experience the world, but by studying how it processes information, we gain a mirror, one that reflects both the extraordinary power of computation and the unique depth of human awareness. If this helped you, consider subscribing.